A client stands with you on an empty plot. She asks one simple question: what will my house cost? You have no drawings, no measurements, nothing but the size of the plot. And she wants an answer today, so what do? You don't guess, you make an approximate estimate, and by the end of this video, you'll know 5 different ways to do it. First two words that students mix up in every exam: estimating and costing. Look at this timeline. Construction starts here and it finishes here. Everything you calculate before the work begins, the probable quantities, the probable cost, that is estimating. It looks forward, and everything you work out after the job is finished from the actual bills and actual measurements, that is costing. It looks back. Estimating looks forward, costing looks back. Write that line down. Why do we bother? 6 reasons, and every one of them is practical. To know if the project is affordable before a single brick is bought, to arrange the funds, to get administrative approval and technical sanction, to invite tenders, to order the right quantity of material, not a truck too much, not a bag too little, and to plan how much labor you'll need and for how long. Now, estimates come in two families. On one side, the detailed estimate made from the working drawings, item by item, every measurement taken. That's the one that goes to tender. On the other side, the approximate estimate made when the drawings don't exist yet, just to know roughly what we're dealing with. Today we're on this side, and the approximate estimate has 5 methods. Let's meet them. Before we touch a single method, let's settle the units, because in estimating, the unit is the answer. Look, measure in one direction only and you get a length in meters, measure in 2 directions and you get an area in square meters, measure in 3 and you get a volume in cubic meters. That's it. That's the whole language. Now, a rate is a little different. A rate always carries the unit of the thing you're measuring, but upside down. Rupees per square meter, rupees per cubic meter, rupees per bed. And that's deliberate because when you multiply, that unit cancels and only rupees are left. So from now on, in every single step, we will write the unit and we will check it. Because a right number with a wrong unit is still a wrong answer. And this is not just good practice. The way every item of work must be measured is laid down in an Indian standard. IS 1200, the methods of measurement of building and civil engineering works. Your syllabus names it directly. Method 1, the plinth area rate method. The most used of all 5. Here's the idea in one picture. Take the plan of your building and measure it out to outside face to outside face, so that the walls sit inside your measurement. That area is the plinth area. Now find a similar building built recently nearby, divide its cost by its plinth area and you have a rate, so many rupees for every square meter, multiply the two and you have your estimate. But be careful what you include. The walls, yes, they're in. A veranda with a roof over it, in staircase room, mumty. Lift well, in but an open balcony, out, a courtyard open to the sky, out. And here is where students lose marks. Plinth area is not carpet area. Carpet area is the floor you can actually walk on. Plinth area is measured out to out, walls and all. And if you want the authority for that, it is IS 3861, the method of measurement of plinth, carpet and rentable areas of buildings. That single code defines all 3 areas. So if a question asks you which code governs plinth area, that is your answer. Now let's actually do one step by step. Step 1. Find the plinth area. Why first? Because every rate in this method is per square meter, so nothing can happen until we know how many square meters we have. 12.5 meters times 8 meters, 2 directions multiplied, so meter times meter gives square meter, 100 square meters. Step 2, pick up the rate. This doesn't come from a formula, it comes from a real building nearby that was recently completed, 14,000 rupees per square meter. Step 3, apply the formula, 100 square meters times 14,000 rupees per square meter. Watch the units, square meter on top, square meter underneath, they cancel. Only rupees survive. 14 lakh rupees, but hold on, we're not finished. That 14 lakhs is only the building. Because a building is not only walls and a roof. Step 4. Add the services, water supply and sanitary work. 8% electrification, another 8%, architectural appearance 1%, and petty supervision and contingencies 4%. Now notice something about the unit here. A percentage has no unit at all. 8% just means 0.08, a plain number. So multiplying rupees by it still leaves rupees. That's why you can never write 8% as a line in your abstract. It isn't a quantity, it's a multiplier. Step 5, total it up. 21% on top of 14 lakhs is 2,94,000. So the project comes to 16 lakhs 94,000 rupees. And remember this pair for the exam sanitary 8, electrical 8, 16% together. One honest warning though, unlike the measurement rules, these percentages are not laid down in any IS code. They are conventional textbook values, so in the exam quote the figure from your own prescribed book. Method 2. Watch what happens to our flat plan now. It stands up because a building isn't an area, it's a volume. Step 1, we already have the plinth area, 100 square meters. Step 2, measure the height from floor level to the top of the roof, 3.5 meters. Step 3, multiply. Square meter times meter, we've added a third direction, so the unit climbs from square meter to cubic meter, 350 cubic meters. Step 4, apply the cubic rate, 4,000 rupees per cubic meter. Cubic meter cancels cubic meter, rupees survive, 14 lakhs. The same answer as before. So why does this method exist at all? Here's why. Suppose this is not a house but a hall and the height goes up to 4.2 meters. Nothing else changes. Now watch both methods. The plinth area method doesn't notice a thing. The area is still 100 square meters, so it still says 14 lakhs. It is blind to height because height was never in its formula. But the cubic content method sees it immediately. 420 cubic meters, 16 lakhs, 80,000 rupees. That difference, 2 lakhs, 80,000 rupees, is the height that the first method simply could not see. And that is the entire reason this method exists. Method 3 is the clever one. For some buildings, nobody cares about square meters. They care about service. Nobody asks how many square meters a hospital has. They ask how many beds. Step 1, identify the service unit. For a hospital, it's the bed. Step 2, count them. 120. Step 3, pick up the cost per bed from a similar hospital, 8,50,000 rupees per bed. Step 4, multiply and look at the unit, beds on top, beds underneath. They cancel exactly like square meters did. 10 crore 20 lakh rupees. The unit doesn't have to be a measurement at all. It just has to be the thing the building is really counted in. Method 4 is for buildings that repeat: a factory shed, a workshop, a godown, same bay over and over. Step 1, count the bays, 8. Step 2, separate them, and this is the whole trick: 6 intermediate bays and 2 end bays. Step 3, the 6 middle ones at 3,20,000 each come to 19,20,000. Step 4, the end bays carry the end walls, so they cost about 25% more, 4 lakhs each, 8 lakhs for the two. Step 5, add 27 lakhs 20,000. Now, if you had simply multiplied all 8 bays by the typical rate, you'd have got 25 lakh 60,000, short by a lakh and 60,000. Notice the unit too, bays times rupees per bay. The bay cancels, rupees survive. If your answer ever comes out in rupees per bay, you've missed a multiplication. And method 5, the most accurate of the 5. Take the walls of your building and unroll them into one straight line, 60 meters of wall. Notice what we've done to the unit. We've thrown away breadth and height completely. So this is a plain running meter, length only. Step 2, price everything below the plinth. Excavation foundation, plinth damp proof course, 4,500 rupees per running meter. 60 meters gives 2,70,000. Step 3, price everything above. Walls, doors, windows, floor, roof, finishing 9,500 per meter. 5,70,000. Step 4, add them. 8,40,000. And you can only add these because both are in rupees. Never add a square meter to a cubic meter. One more name to know: CBRI, the Central Building Research Institute at Roorkee. They surveyed real buildings and found something useful. The material you need is roughly a function of the plinth area. Bigger plinth area, proportionally more cement, more sand, more steel. And here's the neat part about units. Look at that coefficient, 0.0204. It isn't a bare number for the answer to come out in tons. That coefficient must itself be tons per square meter. In any empirical formula, the coefficient always carries whatever unit makes the equation balance. Just remember the coefficients change with the type of building, so use the table in your own textbook. So, 5 methods on one ladder: plinth area rate, the quickest priced per square meter; cubic content per cubic meter for when height matters; service unit per bed or per seat when the building is counted in service; typical bay per bay when it repeats; and approximate quantity per running meter, the most accurate. Notice that each method is really just a different choice of unit. Pick the unit that fits the building in front of you, and the method chooses itself. And before you go, 7 traps that cost marks. Don't swap estimating and costing. Don't use carpet area where plinth area belongs. Don't forget the 8 plus 8%. Don't multiply all the bays by the typical bay cost. Don't expect the plinth area method to notice height. Don't write square meter where cubic meter belongs. Count your directions. And never ever leave the unit of your answer. That's approximate estimating, 5 methods, 5 units, 1 picture each. The notes and practice questions for this topic are free on our Telegram channel, link in the description. Next, we go to part B, the types of detailed estimate and all the technical terms your exam loves to ask. If this made it clearer, do subscribe, keep learning, and I'll see you in the next one.